Okay, in this next section, we're going to look at approximate numbers and significant digits. We have some numbers out there that are exact, and we have some numbers out there that are approximate. Whenever we measure something with, let's say, a tape measure or a ruler or anything, then what you get is an approximate value. Number one, the reason why you get an approximate value is that, it may not touch exactly the line that we're looking at. There's human error with our eyes. And then, we just give an approximation there. Like if you're looking at something, it may look like it's 18.2 inches, but you really don't know. We have some devices that can give us precise measurements. But whenever we, as humans, measure something, for the most part, it's going to be an approximation. Let's look at this example 1. It says if a surveyor measures the distance between two benchmarks as 156.2 feet, we know that it's approximate. Okay, a more precise measuring device may cause us to determine that the length is 156.18. But regardless of the measurement used, we can never determine it exactly. Human error. Okay? Voltage cannot be determined exactly. In the second example, it says if a computer counts the number of students majoring in science or technology and prints this number as 768, then this is exact. Because you have one person as a unit. You're just looking at something and saying, I'm calling it number 1, number 2, number 3. It is determined by a counting process. And a counting process is exact. A measuring process is not. Okay? It says that when we say 60 seconds is 1 minute, 60 is exact because this is a definition. Okay? By definition, there are exactly 60 seconds in a minute. Okay. In the last section, we saw that 2.54 centimeters was an exact representation of 1 inch. That was exact. So next few examples, we're going to determine whether the numbers given are exact or approximate. The speed of sound is 770 miles per hour. This is an approximate value. Okay, something that we measure. A gear has 36 teeth. Well, you can count the gears. So this is exact. Number 6 says 25 math students. This 25 is exact because we went through a counting process. 25 math students had a mean test score of 79.3. This is approximate. Something that we're measuring. Okay? When we talk about measuring, we can talk about being precise, we can talk about accuracy, and those things are talked about in this section, but we're going to focus our attention on significant digits. Okay? Significant digits. And this is something that's used in science classes. It's used in technologies classes. But let's talk about how to determine the number of significant digits. When you look at a number, okay, every number may not be what we call significant. Okay? Every number may not be what we call significant. Okay? Sometimes when we are writing approximate numbers, we may include some zeros so that the decimal point will be properly located. But sometimes those zeros are not significant. So let's talk about what has to happen and how we determine whether how many significant digits a number has. The first thing is that all non-zero digits are significant. So anytime you see a number other than 0, you can count it as a significant digit. The second thing is zeros that are in between two significant digits are significant. So a zero between two non-zero numbers is significant. Zeros placed to the right of both the decimal point and another significant digit are significant. So zeros to the right of the decimal point and another significant digit is significant. That would be something like 1.08. The zero is significant there. Or 0.03. This zero here is significant because it's to the right of the decimal and another significant digit. Zeros placed at the beginning of a decimal problem or before other digits are not significant. So this is significant. This zero, however, is not significant. And zero used as placeholders are not significant. So let's look at this table. The first number we have is 8,700, and it says that we have two significant digits. The first thing you always do is you go and you count the non-zero digits. So we have two digits that are non-zero. And then you look at your zeros. If your zeros are between two significant digits, then you know it's significant. But if they are just placeholders, then they're not. Well, these zeros at the end are placeholders, so we only have two significant digits. If we look at 408,000, the 4, the 0, and the 8 are significant because the 4 and the 8, they're non-zero, but the 0 is between two significant digits, and the other zeros are placeholders. Okay? Now, if we look at 4.0005, all 5 digits there are significant, primarily because these are not placeholders. If this 5 had not been here, if it had been 4.000, then it would have been one significant digit. But because that 5 is there, it shows that they're not just placeholders because there are other numbers behind it. Okay? And this goes back to number 3. Zeros placed to the right of both the decimal point and another significant digit are significant. So these zeros are in between, on the other side of that decimal, though, two significant digits. 0.004, only one significant digit, because the zeros prior to the 4 are placeholders, and there's not another significant digit on the other side of those zeros. 4.000. It says 4, so I have to recant what I said here. I said this only had 1, but it has 4 significant digits. I said if the 5 had been gone, it would only have 1, but it has 4. And mainly it says that the zeros are not required as placeholders and they do not count as significant digits. So I guess essentially it's saying you could write 4, but for some reason they wrote 4.000 as a significant point. In the next example, the 503, those are significant. The zeros on the left hand side of the 503, I'm sorry, they are placeholders. Okay, so only if these zeros are required as placeholders do we not count them significant. These 3 don't have to be there. All right, let's look at some problems. In exercises 9 through 16, it says determine the number of significant digits. So, number 10, this has 3 because they're all non-zero. This one has 2, the 5 and the 2. The zeros are placeholders, and whenever you use them as placeholders, they are not significant. Number 12, we have 2 here. These zeros are used as placeholders. Here we have 4. That 0 is a placeholder, so you don't count it. And in number 14, this is a tricky one. We have one significant digit when we're dealing with 7,000 because those are placeholders. Here, because they made a point of putting 0.0, then that makes it important to us. So here we have 5 significant digits. Number 16, same thing, 9.000. Those are not placeholders. They want that number to be exactly that. We have 4 significant digits. And here we only have 1 significant digit. All right, let's look at some other exercises. It says to round off the given approximate numbers to 3 significant digits and then to 2 significant digits. Well, when we look here, this 53.72 has 4 significant digits, and we need to make it 3 significant digits. Okay? So what we can do, we can call this 53, and we know that if we round here at the hundreds place, that's below 5, so it becomes 53.7. That's that number to 3 significant digits. It's part A. Part B is to 2 significant digits. So that means I need to get rid of the numbers on the right of decimal. Well, 53.7 is closer to 54. Because this number is bigger than 5, we round up. So that's 3 significant digits, 2 significant digits. Let's look at the next number, 32,768. Here we have 5 significant digits, and we need to get this to 3. Well, we have 32,768. Well, 32,768 is closer, because we need 3 significant digits. It's closer to 32,800 than it is to 32,700. And here we have 3 significant digits. The zeros at the end are like placeholders. And to get to 2 significant digits, well, 32,768 is closer to 33,000 than it is to 32,000. So here, this makes our 2 significant digits. Let's look at number 36. 0.6350. That has 4 significant digits. To make 3, we could just leave off that last 0. And to make 2 significant digits, 0.65 here means we go up by 1, 0.64. Okay, so this was a brief overview in approximate numbers and significant digits.